Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about how to size a furnace based on Manual S ACCA standards for double stage and modulating burners, all right? All right, let's get into it. So everything starts with the heat load calculation. So with the heat load, what we have in here, we're going to put this in pink. That's called the heat loss. Actually, the heat loss is written right there, okay? Heat loss. Exactly. So just to remember a little bit, a brief review is going to be Manual S. See, in Manual S, pretty much what we have based on ACCA standards, ACCA, America Air Conditioning Contractors of America, this is actually what the code recommends. What we have is the following: when you're sizing heating, because there is also another part which is sizing for cooling. So now in this case we're sizing for heating. There are three different parts. Number one is depending on your furnace. I'm going to put this in green actually. If your furnace is single stage, oh, actually I'm going to put this in green. Okay. So if your furnace is single stage, multi-stage, stage, or modulating burner, modulating burner. Okay, so depending on which type of furnace you are going to select, you have different parameters. For example, actually for all of them, they have the same parameters, which is the same limits, which is your equipment has to be sized from 100% to 140%. That's what they recommend. That's preferable. But if you cannot meet the design CFM, actually the target CFM, then you have to jump to the next size furnace. Since you are jumping in sizes, then you might have more you might present more capacity or percentage. So in other words, you can go up to, let's put up to 200%. 200%, but depending on CFM. We're going to go back to yellow. Yeah, depends on CFM. Depends on CFM, right? In other words, you can jump to the next size if the CFM within this range is not enough. Depends on CFM. Let's go when it's not enough. When it's not enough. It's not enough. Okay. All right, so let's get into it. Let's continue with this. Okay, since we have our heat loss, we're going to put in here this is a quick and easy calculation. So as we know, the overheating percentage is going to be equal to the capacity divided by the load. So what is the capacity? Let's put in here capacity divided by load, okay, times 100. All right, so overheating percentage is going to be the capacity. But what capacity? As we've seen, let's put this in pink. Now this is a double stage. So since it's a double stage, the furnace starts in the beginning with the first stage, which is low fire. Low fire means like you have a lower capacity. And then if it needs heat, if you need to comply, then it goes to the second stage. Okay, so or in other words, if you are calling for heat and the house is very cold, you know, actually the maximum capacity is gonna be the second stage. So the beginning capacity first stage, the second capacity second stage. So now we need to think about which furnace are we going to choose. We have three options in here. So let's go here. Option number one is a 30K, see, 30K, 40K, or 60K based on this heat loss. But how do you know the model, what the nomenclature of the model is? You can find that in the internet, in the manufacturer specifications data sheet. And if it's not in the internet, you have to contact the representative. Every brand has their own representative. For example, York, Lennox American Standard. If you cannot find it online, there is always in the website contact support, and you can always ask them to provide the specification, the nomenclature, or what is the data sheet of this product. Okay, but since this is available online, that's why I'm using this as an example. Okay, so 30K is not going to comply with the heat loss of 34. So possibly it's going to be 40K or 60K. Let's go for 40K. So if it's 40K, we have to remember that when we're sizing this equipment, we need to, when we're sizing double stage, 2 stages, we're going to take into account the second stage, the maximum capacity. See, this is second stage, and this is first stage. So the second stage is equal to, which one do we choose? Do we choose the input or the output? The output. Okay, so since the output is, I'm going to put that in pink in here. So 38,400 BTUs per hour. And then I'm going to continue with the load, which is the heat loss. So the heat loss is going to be equal to 3,400, 949. And of course times 100 just to make it as a percentage. So the overheating percentage is going to be how much? So the overheating percentage in this case is 110%. Okay, 110%. And 110% is within the preferable range. So technically I could choose this furnace. Okay? But what about the second case? Let's take a look at the 60K. The same example and the 60K. We're going to put this as option 1. Let's go for option number 2. So overheating percentage is going to be equal to the, again, we're going to take into account the output capacity of the second stage, which is 57,600, and then divided by the heat loss. The heat loss equals to 34,949, and this is going to be times 100 because we want to express this as a percentage. If you don't put 100, then it's like a manual S, a factor, oversize factor. Okay, so how much would that be? If we do the calculation, that's going to be 165%. There we go. So 165% is not preferable, but this is still within range, 140 to 200. So, and also we're going to have a bigger CFM. Of course, when you're choosing a bigger furnace between 40K and 60K, 60K furnace, 60,000 BTUs per hour is bigger, therefore it will be more expensive. But that depends on the designer, that depends on, it's kind of an executive decision. You can either choose the 110, 165, everyone is different. Sometimes people prefer it to go more conservative, other people tries to go more better safe than sorry. So personally for my house, honestly, I would take this. It's going to be more expensive, maybe oversized, but you know, in case there is an issue with the ductwork or losses, just in case I would choose this one. So now what is the second part of this? So as we know, second stages, actually in the first stage is gonna work as 70%, 60% of the capacity, and then it goes to the full capacity in second stage. The first stage, when this single stage, of course, is more economic, but it only works as an on and off, either on or off. So multi-stage actually refers mostly to two-stage furnaces, and it's more efficient. And the most efficient one is modulating burner. Okay, that's going to pretty much control in 1% increments from 40% or 35, or depending on the manufacturer, to 100% in 1% increment. So there is more control in that case. But it's also more expensive. So this is less expensive, two-stage more expensive, modulating burner more expensive, but more efficient. Okay, so for the modulating burner, it's going to apply the same procedure. All right, so now that we have what we did in here, now what we know how to size the equipment based on ACCA Manual S for two-stage furnaces and modulating burners, just we're gonna go a step further. What is the design CFM? As we know in other videos, we have the target. Okay, so what's the target CFM? Target CFM, let's go with the target CFM. The target CFM is going to be based on the sensible heat equation, which is Q equals 1.08 times CFM and times delta T, right? Times delta T. Okay, what is the sensible heat? The sensible heat is the heat loss. So for this case, we're going to have 34. And we did this calculation on the other video, but it's always good to repeat just so retention is matter of repetition, I've heard, right? So TFM times delta T, and the delta T, we have in here my delta. That's going to be 72 minus 14, which could be also 14 minus 72. The only difference is the sign. Okay, so CFM in hitting the target CFM is going to be 558 CFM. Okay, that's what we're targeting. That's my goal. Okay, now we're going to go check the design CFM. When we're going to go to the design CFM, we're going to actually select the real CFM. So this is the heating CFM coming from the catalog for this equipment, which is the 60K furnace. So in this case, let's take into account the static pressure. Could be 0.5 or could be 0.7, depending on how much resistance you're gonna have in your ductwork, the longest path. So in this case, let's go for 0.7. And in 0.7, the one that is closer to 505.8 is 644. There we go. So if it's 644, and one point in here, my maximum CFM is at 0.5 is 1139 CFM. So what happens if my furnace requires a target CFM of 1200 CFM? And my maximum is 1139 in this model. Then we jump to the next model, which is 80K. So 80K will have more CFM, and of course will have more overheating percentage. It will go up to 180, 195. So that's when we go up to 200. When we go up to 200 is when the enough is not enough. But in this case, there is plenty of CFM. And then that would be the design CFM. Well, let's put in here heating. See, heating CFM, okay, equals to 644. There we go. Heating CFM equals to C444. And in this case, we're going to put the dip switches, and that's mostly for the technician. The dip switches could be on and off, but they already know what to do with the dip switches on and off. But in your report, you can always put the design CFM is going to be 644 for heating CFM, because there is also cooling CFM. All right, but we're going to make another step further, which is in the future we're gonna talk about ductwork. When we're talking about ductwork, the design CFM is the starting point. Design CFM, because with this design CFM, you're gonna be able to do CFM distribution, and we're gonna use the longest path. See, CFM to your rooms, to everyone, but everything starts with the design CFM. And in other videos, we saw that the cooling CFM is greater than the heating CFM. So for ductwork, we usually utilize the cooling CFM. Why? Because the cooling CFM is greater, and if it's greater, of course, it's going to comply with the heating CFM too. All right, and last thing. When you buy the furnace, usually you have to read these stars in here. That means that it's going to come in factory default in these settings. And that's part of the technician, but it's just a step further for the technician, for the installer, and that actually helps a lot. All right, so I hope you enjoyed this video, and please hit the like button and share and subscribe. Alrighty? Thank you so much.